technologies we still can't replicate. What they left behind reveals engineering achievements that modern science struggles to understand. The precision-cut stone blocks at Quilap in Peru demonstrate construction techniques that challenge contemporary capabilities. The fortress sits at 3,000 meters above sea level, where oxygen levels make physical labor extremely difficult. The massive limestone blocks fit together with joints measured in millimeters despite weighing several tons each. The builders achieved this precision without metal tools or wheeled vehicles. Modern stone cutting equipment cannot consistently produce the tolerances found in these ancient walls. The geometric complexity of Quilap's design reveals mathematical knowledge that appears fully developed without evidence of gradual learning. The circular structures incorporate sophisticated drainage systems that prevent water damage after 1,000 years of exposure to mountain weather. The engineering accounts for seismic activity through flexible joints that allow the walls to move during earthquakes without collapsing. Contemporary earthquake-resistant construction uses similar principles that weren't supposedly developed until modern structural engineering emerged. The Tiwanaku Temple complex in Bolivia presents another example of construction techniques that exceed modern capabilities. The builders transported stone blocks weighing over 100 tons across distances of 60 kilometers without wheeled vehicles or large animals. The precision fitting of these massive stones creates structures that remain stable after centuries of seismic activity. The construction methods left no tool marks or evidence of the techniques used to shape and position these enormous blocks. Modern cranes cannot lift stones of this size to the heights achieved by ancient builders. The Mayan canal systems, discovered through 2025 LIDAR surveys, reveal hydraulic engineering that rivals contemporary water management projects. The networks include automated flow control mechanisms that adjust water distribution based on seasonal rainfall patterns. The engineering demonstrates understanding of fluid dynamics principles that weren't formalized until the development of modern hydraulic theory. The canals maintain consistent water levels across vast distances through elevation changes that require precise mathematical calculations. The water management systems incorporate filtration methods that produce clean drinking water from contaminated sources. The filtration uses natural materials arranged in specific sequences that remove bacteria and chemical contaminants. Modern water treatment facilities use similar multi-stage processes that require sophisticated understanding of chemistry and biology. The ancient systems operate without external power sources or mechanical pumps, while maintaining effectiveness that exceeds many contemporary water treatment methods. The astronomical accuracy achieved by ancient civilizations using simple observation techniques challenges modern understanding of scientific methodology. The Antikythera mechanism from ancient Greece calculated planetary positions with precision that wasn't matched until the development of modern computers. The device contains gear ratios that account for the irregular motion of celestial bodies through mechanical calculations. Modern reproductions require precision machining that was supposedly impossible with ancient tools. The original mechanism demonstrates manufacturing tolerances that current watchmakers struggle to achieve. Mayan astronomical observations recorded planetary movements with accuracy that wasn't equaled until the invention of telescopes. The calculations account for precession cycles lasting thousands of years and predict eclipses with precision measured in minutes. The observations were made with naked eye techniques that modern astronomers cannot replicate despite understanding the mathematical principles involved. The ancient calculations required generational coordination and record-keeping systems that preserved data across centuries. The implications challenge fundamental assumptions about technological development and knowledge transmission. Ancient civilizations appear to have possessed technical capabilities that modern science assumes require centuries of gradual development. The techniques appear fully formed in the earliest archaeological evidence, without transitional stages or experimental failures. This suggests either rapid technological advancement or inheritance of knowledge from sources that left no clear archaeological record. The precision achieved in ancient construction projects exceeds the capabilities of many modern building techniques. Stone blocks cut with tolerances measured in fractions of millimeters demonstrate control over materials that contemporary methods struggle to match. The durability of ancient structures often surpasses modern construction despite exposure to centuries of weathering and seismic activity. The engineering principles used in these projects inform current discussions about sustainable construction and earthquake-resistant design. The study of these ancient technologies reveals that human knowledge may be more fragile than contemporary societies assume. Technical capabilities that required centuries to develop can disappear within a single generation if not properly transmitted. The evidence suggests that ancient civilizations possessed sophisticated understanding of material science, engineering, and mathematics that modern science is still working to recover and understand. The revelation that human technological capability may have actually regressed in some areas forces reconsideration of assumptions about progress. Modern civilization assumes that knowledge accumulates steadily over time, with each generation building upon previous achievements. The archaeological evidence suggests that human societies have repeatedly achieved technical capabilities that were subsequently lost and required centuries to redevelop. This pattern of knowledge loss and rediscovery challenges linear theories of human advancement. Contemporary research into ancient technologies reveals that modern science may have taken developmental paths that ancient practitioners avoided. The focus on mass production and standardization may have eliminated techniques that produced superior results through individual craftsmanship and specialized knowledge. Ancient methods often required decades of training and practice that modern educational systems cannot accommodate. The loss of these techniques represents irreplaceable knowledge that shaped human civilization for millennia. These discoveries force us to question not just what ancient civilizations achieved, but whether our understanding of what constitutes a lost civilization needs fundamental revision. The evidence suggests that human societies possessed capabilities and knowledge that challenge every assumption about technological development and cultural achievement. Yet the most startling revelation may be that some of these supposedly vanished civilizations never actually disappeared at all. The survivors, civilizations that hid in plain sight. The archaeological record reveals a different story entirely. Many civilizations we call lost never actually disappeared at all. They adapted, evolved, and continued existing in forms that fooled historians for centuries. The 2025 anthropological research reveals a startling pattern across every continent, where indigenous groups dismissed as primitive are actually descendants of advanced ancient civilizations. These communities maintain sophisticated knowledge systems, complex technologies, and intricate social structures, while presenting outwardly simple lifestyles that protected them from conquest and cultural destruction. The Chachapoya civilization demonstrates this survival strategy perfectly. Known as the warriors of the clouds, they built elaborate cities high in the Andes Mountains and maintained complex societies that rivaled the Inca Empire. When Spanish conquistadors arrived, the Chachapoya people didn't vanish into history books. Their descendants still live in the Sierra regions, speaking languages rooted in Torona traditions while maintaining themselves as caretakers of the earth. They preserved their heritage through deliberate cultural camouflage, appearing less sophisticated to survive colonial suppression while secretly maintaining ancient practices and knowledge systems. The 2025 excavation of a Chachapoya Cholpa tomb in Research Area No. 1 provides concrete evidence of this cultural continuity. The burial site contained a slate pendant and ceremonial axe that demonstrate sophisticated craftsmanship and symbolic complexity. The artifacts show technological capabilities that contradict assumptions about primitive mountain communities. The burial practices revealed in the tomb connect directly to oral traditions that local communities have maintained for centuries, proving that their cultural knowledge accurately preserved ancient practices that archaeology is only now documenting. This pattern of deliberate concealment appears across multiple continents, where advanced civilizations chose invisibility over extinction. Communities that built massive stone cities, developed sophisticated agricultural systems, and created complex astronomical calendars learned to hide these achievements when faced with conquest or cultural erasure. The knowledge survived through oral traditions that passed down detailed information about lost cities, advanced technologies, and historical events that modern archaeology is now confirming as remarkably accurate. The survival techniques these civilizations developed required extraordinary social coordination and cultural discipline. Entire populations had to agree to suppress visible signs of their technological achievements while maintaining the knowledge systems internally. This meant abandoning monumental architecture, simplifying public ceremonies, and hiding advanced tools and techniques from outsiders. The strategy worked so effectively that historians spent centuries categorizing these communities as primitive societies rather than recognizing them as sophisticated civilizations in disguise. Traditional practices that appear simple to modern observers often represent sophisticated solutions to complex problems developed by advanced ancient societies. Agricultural techniques that seem basic actually incorporate knowledge of soil chemistry, climate patterns, and ecological relationships that took centuries to develop. Construction methods that appear primitive use engineering principles that create earthquake-resistant structures lasting for millennia. Medical practices dismissed as folk remedies contain pharmaceutical knowledge that modern science is only beginning to understand and validate. Colonial suppression created powerful incentives for advanced civilizations to hide their true capabilities. European colonizers systematically destroyed evidence of indigenous technological achievements to justify conquest and cultural domination. Communities that revealed their advanced knowledge faced complete destruction, while those that appeared primitive often survived with reduced interference. This created evolutionary pressure that selected for civilizations capable of maintaining dual identities, where public simplicity masked private sophistication. The oral tradition preservation systems, these communities developed rival modern information storage technologies in their accuracy and durability. Stories passed down through generations contained precise geographic coordinates, detailed technical specifications, and accurate historical chronologies that archaeology confirms centuries later. The storytellers developed memory techniques that preserved complex information across dozens of generations without written records. These oral libraries contain knowledge about ancient cities, lost technologies, and historical events that no written source documents. Modern research techniques are revealing the true sophistication of communities that successfully hid their heritage for centuries. The Old Kingdom Egyptian Genome Study published in Nature demonstrates how genetic analysis can reveal cultural persistence rather than disappearance. The research shows that populations maintain genetic and cultural continuity across millennia despite political upheavals and territorial changes. This genetic evidence supports the theory that many supposedly vanished civilizations actually survived through transformation and adaptation rather than extinction. Linguistic studies reveal that languages dismissed as primitive actually contain technical vocabularies for advanced concepts in mathematics, astronomy, and engineering. Archaeological investigation of indigenous sites uncovers evidence of sophisticated technologies and social organization that contradict assumptions about primitive lifestyles. The accumulated evidence shows that apparent simplicity often masks complex knowledge systems that served community needs more effectively than visible monuments to power. The ethical implications of studying communities that successfully concealed their heritage create complex dilemmas for researchers. These groups developed survival strategies that protected their knowledge from exploitation and destruction for centuries. Modern scientific investigation potentially exposes secrets that communities deliberately kept hidden for their own protection. The research benefits may conflict with community interests in maintaining cultural privacy and autonomy over their own historical narratives. The definition of civilization itself requires reconsideration when evidence shows that technological advancement and social complexity can exist without the monumental architecture and written records that historians traditionally use to identify advanced societies. These hidden civilizations developed different expressions of sophistication that emphasize sustainability, social harmony, and ecological integration rather than military conquest and urban expansion. Their achievements appear in sophisticated agricultural systems, complex social organizations, and sustainable resource management rather than pyramids and palaces. The discovery that lost civilizations survive in hidden forms transforms our understanding of historical processes and cultural resilience. These communities prove that human societies can successfully navigate existential threats through adaptive strategies that preserve essential knowledge, while sacrificing visible achievements. Their survival demonstrates that civilization is more flexible and resilient than traditional archaeology suggests, capable of transformation and concealment that allows ancient wisdom to persist through periods of upheaval and change. The evidence forces us to reconsider assumptions about which civilizations truly disappeared and which ones successfully adapted to survive in forms we fail to recognize. Many communities we encounter today may represent the living descendants of advanced ancient civilizations that chose survival through transformation rather than extinction through resistance. Their continued existence raises fundamental questions about how these ancient societies maintained contact with each other, then whether their survival strategies, how ancient civilizations were connected distances. Archaeological evidence reveals the sophisticated networks that enabled this coordination and cultural exchange. The discoveries challenge every assumption about ancient isolation and prove that our ancestors lived in a connected world that spanned continents. The 2025 research shows that ancient civilizations operated within vast networks that moved goods, ideas, and people across distances that historians claimed were impossible to traverse without modern technology. The Garamantes provide the most compelling example of how civilizations thrived through network connections despite environmental challenges. These desert dwellers built cities in the Sahara that supported tens of thousands of people through sophisticated underground irrigation systems called phagorids. Dating back to 500 BCE, their urban centers controlled trade routes between Rome, Egypt, and sub-Saharan Africa. The Garamantes transported ivory, gold, and slaves across vast stretches of desert, accumulating wealth that supported complex urban civilization in one of Earth's most challenging environments. Their prosperity depended entirely on maintaining connections within continental trade networks. The Roman Basilica, discovered beneath London in February 2025, reveals how these networks operated at the local level. The structure contains imported marble columns, exotic mosaics, and architectural elements that originated from quarries across the Mediterranean. The building materials traveled thousands of kilometers through established trade routes that connected Britain to North Africa, Greece, and Asia Minor. The construction demonstrates how network connections enabled civilizations to access resources and technologies from distant regions, creating architectural achievements that would have been impossible using only local materials. The Sogdians dominated trade routes from the 4th to the 10th century CE and demonstrated how intermediary civilizations facilitated global connections. They spoke multiple languages, navigated complex political relationships, and maintained cities that served as cultural crossroads where Persians, Chinese, Indians, and Greeks conducted business together. Samarkand and Bokhara became vibrant oases where diverse cultures interacted and exchanged knowledge. The Sogdians operated as cultural brokers who connected distant civilizations through sophisticated diplomatic and commercial networks that spanned continents. Identical technologies appearing simultaneously in civilizations separated by oceans prove that ancient knowledge transmission operated faster than traditional theories suggest. Bronze working techniques emerged in Europe, Asia, and Africa within decades of each other around 3200 BCE. Mathematical concepts, including the concept of zero, appeared in India and Mesoamerica at nearly identical times. Astronomical observation techniques that track planetary movements with identical precision developed in Egypt, Babylon, and China during overlapping periods. The simultaneous development suggests coordinated knowledge sharing across continents through networks that historians are only beginning to understand. The collapse of network connections triggered cascading failures across multiple continents. When the Bronze Age collapse occurred around 1200 BCE, civilizations from Greece to Egypt to Mesopotamia failed simultaneously. The collapse wasn't caused by individual disasters, but by the breakdown of trade networks that connected these civilizations. The interruption of copper and tin supplies necessary for bronze production created economic crises that toppled governments across the Mediterranean. The network failure demonstrated how interconnected civilizations shared both prosperity and vulnerability. The Hittites controlled trade routes from the Aegean coast to Mesopotamia around 1300 BCE and maintained diplomatic relationships with Egypt, Babylon, and other major powers. They created the world's first known peace treaty with Ramesses II of Egypt and developed sophisticated approaches to international relations. The Hittites absorbed cultures rather than crushing them, which proved both their strength and their weakness. Their empire thrived through diplomatic networking, but collapsed when these relationships couldn't be maintained during periods of political upheaval. Communication systems that coordinated activities across vast distances operated without leaving obvious archaeological evidence. Civilizations synchronized their activities across continents through methods that historians struggle to identify. The timing of major construction projects, religious ceremonies, and political changes shows patterns that suggest coordinated planning across multiple civilizations.